Okay, hello dear students, welcome back to our social network analysis course. So in the previous session we learned about graph basics, graph representations and different types of graphs. Now it's time to learn how we actually explore or traverse a graph. Imagine Facebook has millions of users. If Facebook wants to analyze every user, can it simply jump randomly from one user to another? No. There must be a systematic way of visiting every user exactly once. So the topic is graph traversal algorithms, namely depth first search and breadth first search. So these are among the most important graph algorithms and are used in Google Maps, Facebook, web crawlers, AI robotics, and many other applications. So, uh, before learning the algorithms, let us understand why traversal is needed. Suppose Facebook wants to calculate the average age of its users. Can Facebook ask everyone simultaneously? It's not practical. Instead, it starts from one user, then visits that user's friends. After that, it visits their friends. Eventually, every connected user is visited. This process is called the graph traversal. So that a good traversal algorithm should satisfy two important conditions. Every node should be visited. No node should be visited more than once. So to solve this problem, computer scientists developed two popular algorithms, DFS and BFS. So the first concept is depth first search. So DFS. So the word depth gives us the clue. Instead of exploring nearby nodes first, DFS keeps moving deeper into the graph until it cannot move further. Imagine entering a large building with many corridors. At every junction you choose one corridor and keep walking until you reach a dead end. Only then do you return and explore another corridor. This is the logic. So the DFS uses the stack data structure. The stack follows the last in first out principle. So the DFS algorithm. So this is the DFS algorithm. So see this graph. First we are visiting the vertex V1. Then we are visiting the first neighbor V2. And from V2 we are visiting the neighbor of V2. That is V4. After there is no neighbors for V4. Then only we are moving backward to the V2 and visiting the next neighbor of V2. Likewise, the depth first search algorithm works. So for example, start with a, this is our graph or it may be a tree. Start with the root 0, root node. So mark it as visited and push it into the stack. So 0 is pushed into the stack. So initially the traversal order is empty. So next, uh, remove the node from the stack and put it in the DFS order. So the 0 is popped out from the stack and put it into the output order. So then push the neighbors of 0. So the neighbors of 0 are 1 and 2. So the 1 is pushed first and 2 is pushed at second. So next we are visiting the we are popping out the element from the stack. So the top of the element 2 is popped out and the neighbors of 2 is pushed into the stack. So first we visited 0, then 2 and then neighbor of 5. Neighbor of 2 is 5. So again pop the 5 from the stack and push all the neighbors of 5. So there is no neighbors for 5. So next the element in the stack is 1. So pop the element 1 from the stack and put it in the DFS order. And then push all the neighbors of 1. So 1 is popped out and placed into the DFS order. The neighbors of 1 is 4 and 3. So first 3 is pushed and 4 is pushed. Then pop the element 4 from the stack and push the neighbors of 4. So there is no neighbors for 4. So simply pop the 4 and put it in the DFS order. So at last there is an element 3 in the stack. So pop the element 3 and put it into the DFS order and push all the neighbors of 3. So there is no neighbors. So at last only pop the element 3. so that the final DFS order is 0, 2, 5, 1, 4, 3. So this is the principle of DFS. So the next algorithm is BFS. So BFS starts from the node and visit all its immediate neighbors first and then moves to the second level by traversing their neighbors. So the BFS uses the queue data structure. So this is the algorithm of BFS. So for example, here see this graph. First V1 is visited. So the neighbors of V1 is V2 and V3. So both V2 and V3 is visited first. So V2, V3 will be visited. Then the neighbors of V2 will be visited. So the neighbors of V2 is V4 and V5. So likewise it proceeds. So the BFS algorithm uses the queue data structure, which follows the first in first out principle. Consider this graph. So it contains the vertices A to H. So initially every node is not visited. So visited array is marked as 0. So Q is initially empty. So first select the root node A, mark it as visited and NQ into the queue. Insert into the queue. So next is the neighbors of Q is B and C. So mark the B and C as visited and pop the DQ the element from the queue. So initially we have DQ'd A and NQ'd the neighbors of A, B and C. It means mark the B and C as visited. It means place 1, 1. So the next one, in DQ the front of the queue B. So and then NQ the neighbors of B. Neighbors of B are D, E. So D and E is marked as visited. It means the array is placed as the 1. So now the front of the queue is C. So C is removed from the queue and put it into the output. Then mark all the neighbors of C as visited. So now C is added into the output. The neighbors of C is F and G. So F and G is inserted into the queue. So F and G is marked as visited. Now remove the D from the queue and mark all the neighbors of D as visited. So now D is removed from the queue and added into the output. So the neighbors of D is only H. So it is also marked as 1 and also inserted into the queue. Now remove E from the queue and mark all the neighbors of E as visited. So there is no new neighbors. So that E is simply removed from the queue and added into the output. And the next one F. F is removed from the queue and then added into the output. So and then GH, it means there is no new neighbors, so that the already inserted elements only removed from the queue. So after F, G will be removed from the queue and added into the output. So and for F also there is no new neighbors, so again remove H from the queue and added into the output. So now the queue will be empty. So this is the BFS order: A, B, C, D, E, F, G and H. So this is what the BFS and DFS algorithm